One thing this question does not tell us is how the loops are arranged with respect to each other. So let's consider a couple of different cases. First, let's think about two loops that are coplanar but are not coaxial. So they're basically sitting right next to each other. So let's say this is the primary loop and that this is the secondary loop. So they're sitting next to each other, and the current in the primary is increasing clockwise by 1 amp every second. So in the primary loop we have a clockwise current, and it's increasing by 1 amp every second. So if it's going clockwise, then the magnetic field that it's making, if we use that second right-hand rule to determine magnetic field direction that's made by a current, we would grab the loop with thumb in the direction of the current, and we would find that our fingers sweep downward. So think about grabbing this edge. Fingers sweep downward inside this loop, and they would sweep upward outside the loop. So here the magnetic field made by this loop is upwards, and inside this loop it would be upwards as well. So this is the magnetic field that's made by the primary. If the current is increasing, this magnetic field is increasing. And of course we remember that loops don't like changes in flux. So if this is upwards out of the screen and getting bigger, then this loop is going to make some downward. So this is the induced magnetic field made by the second loop to counteract the increasing out of the screen upward magnetic field made by the primary. So that means the secondary is going to have a current flowing around it. And let's think about how we need to grab this second loop so that our fingers sweep downward inside the loop. So we would have to grab the edge of the loop so that our fingers sweep downward, mimicking this direction of the induced magnetic field, and we would find that we have also a clockwise current that is going around the loop. Now if the current is increasing clockwise by 1 amp per second, that means the increase is steady. And if the increase is steady, then the induced magnetic field is steady, and the induced current will also be steady. So the current in the second loop is constant I induced, and it would be in the clockwise direction. Now let's think about if the loops are not only coplanar but coaxial. What I mean is you have one loop inside the other. So let's say that's the primary, and the secondary is inside the primary. So once again, if we have this clockwise increasing current, then inside the primary loop there will be into the page or into the screen magnetic field. So that's the magnetic field made by the primary. It's increasing. It's getting bigger and bigger as the current in the primary increases. So that means there will be induced, so this is the B induced by the secondary coil to try to counteract that increasing downward into the screen magnetic field from the primary. So if we think about grabbing this loop so that our fingers sweep upward inside it, we'll find that the current ends up, our thumb, the direction of the current ends up going in this direction. So the loop, the secondary loop makes a counterclockwise current, but since this outer loop has a current that's increasing steadily, then there will be a steady increase in the flux through the secondary loop that is into the screen, and so the response and the current will also be steady. So there will be a constant I induced in the secondary, and it will be going in the opposite direction to this first scenario. But in either case, you know, depending on how the loops are arranged, you can either get a clockwise or a counterclockwise current in the secondary, But in both instances, since the increase in current in the primary is constant, the increase is constant, then the response of the secondary and the induced current in the secondary will also be constant.